This is the second half of a review of all the derivative rules we learned in first semester AP Calculus AB. If you missed the first half of the review, go ahead and click the link that should appear in the upper right-hand corner. To find the derivative in problem number 9, we will use the product rule. F of x is this yellow factor times this blue factor. When you do the product rule, first you take the derivative of the first factor. So the derivative of the outer function here will be 2 times parentheses, and then I've still got the inner function x to the third power minus 4. I've got to do the chain rule and multiply by the derivative of this inner function. So that will be 3x squared. So everything you see so far is the derivative of the yellow factor. The first time through, you leave the blue factor alone. So I'm just going to bring down the 2x plus 5 to the third power unchanged. And then I put a plus. Now I'm going to go through the two factors again. The second time through, you leave the first factor alone. So I'm going to just bring down the x to the third power minus 4 squared. And now I take the derivative of the second factor. So taking the derivative of the outer function, I'm going to put the 3 in the front, reduce this power by 1. So that is squared. And I have 2x plus 5. But the chain rule demands that I multiply by the derivative of the inner function. The derivative of 2x plus 5 is 2. So I multiply by 2. Alright, so really this whole thing is an expression of the derivative. I might have to zoom out a little. In the directions we are told to factor completely, so that is what I'm going to do. But first I'm going to clean it up slightly. I have the 2 times 3, so that's going to become a 6 in the front, and I will put the x squared out in the front. I see the 2 times 3 right here, so again I will put the 6 in the front. So far we have this. Now the fun with factoring begins. So I notice that we have a 6 in each term. So I'm definitely going to pull out a 6 as part of my GCF. I also notice that we have x to the third minus 4 in the first term, and we have x to the third minus 4 in the second term, squared. So that will be part of my GCF. So let's put x to the third power minus 4 out front. Be careful with what exponent you want to pull out. So this is like a 1 power, and this is the second power. You always take out the lower power. So I'm going to take out just x to the third power minus 4 to the first power. But then I notice that we have another common factor, 2x plus 5. We have a 2x plus 5 here and here. So that'll be part of the GCF. So I have 2x plus 5. What power should I include in my GCF? You always go with the lesser exponent. And in this case, that will be 2. So I'm going to put the second power. So all of that will be outside the parentheses in the front. To figure out what goes on the inside, I need to divide each term by everything you see here. If I divide by 6, the 6 will be gone. I'm still going to have x squared, so that's going to be there. The x to the third power minus 4 cancels out, so there will be none of that. I see 2x to the fifth power to the third power, and then I'm factoring out 2x to the fifth power squared. When I divide these, I actually subtract the exponents. So it's like I'm doing 3 minus 2 right here. So that's going to leave 2x plus 5 to the first power. So I'm going to have just 2x plus 5 in these parentheses. Moving on to the second term. I divided by 6, so there will be no 6. That's gone. I'm dividing x to the third power minus 4 squared by x to the third power minus 4. So I'm going to subtract 2 minus 1 as I divide. That's still going to leave behind one factor of x to the third power minus 4. In fact, because there is no remaining exponent, I don't even really need these parentheses. So I think I'll just leave it like this. Okay, and that is it, because the 2x plus 5 squared and the 2x plus 5 squared, those cancel out completely, so those are gone. On my next step, I'm just going to copy down everything that you see, but I will distribute the x squared throughout this binomial. X squared times 2x will be 2x to the third power. X squared times 5 is 5x squared. And I bring down x to the third power minus 4. I'm looking for like terms, and I see that we do have 2x to the third power plus x to the third power. So on the next step, this will become 3x to the third power. So this is the final answer for number 9. For number 10, we have a function inside of a function inside of a function. So we will have to use the chain rule 3 times. But let's start with the outer function. So let's take the derivative of the natural log of this yellow stuff. We learned a long time ago that the derivative of natural log x is 1 over x. So the derivative of natural log yellow stuff will be 1 over yellow stuff. So we can write y prime is equal to 1 over the yellow stuff, which is natural log x to the third power. But because this is not just an x in the denominator, but a whole function, we have to use the chain rule and multiply by the derivative of this inner function. So now we're taking the derivative of the yellow stuff. But again, we are taking the derivative of a natural log. The derivative of natural log, remember, is 1 over x. But because we don't have a plain old x in here, then we're going to have 1 over x to the third power. But because this is not just a plain old x, we have to do the chain rule again and multiply by the derivative of this inner function. The derivative of x to the third power is 3x squared. When I clean this up a little bit on my next step, I'm going to put 3x squared in the numerator, and I'm going to put x to the third power in the front. So I have 3x squared over x to the third power times natural log x to the third power. The two x's in the numerator will cancel out 2 of the x's in the denominator. So I will be left with y prime is equal to 3 over x natural log x cubed. And this is the final answer. Actually, this is an acceptable answer, but we can simplify it even more. Let me quickly remind you of a property that we know about logarithms. If I have, for example, the natural log of a to the c power, we've learned that we can move the exponent to the front and write this as c times the natural log of a. This is just a property of logarithms. But notice in the denominator we have natural log x to the third power. According to this property, I can take the 3 in the exponent and move it out to the front. So I will still be left with the x, but if I take the 3 and move it out to the front, I'm going to have the 3 right here. So here's another version of the answer, but obviously the point of doing this would be so I can cancel out the 3's. So a more simplified version of the answer would be 1 over x natural log x. All 3 of these would be acceptable, but the third one is what you would probably see on a multiple choice question. Before we do number 11, I need to remind you of the relevant rule that you just need to memorize. The derivative of log base a of x is 1 over x. So far that should remind you of the derivative of natural log would be 1 over x. But because this is log base a, we have an extra factor of natural log a stuck in the denominator. I'm going to use this rule right now, but of course, because I have a 4x on the inside, instead of just putting an x, I'm going to put 4x right here, and then I'm going to use the chain rule. So y prime will equal 1 over, and again, instead of writing 1 over x, I'm going to put 1 over 4x. But then I have my natural log of 3, where I have the natural log of a. But because this was not just a plain x, it was 4x, I need to now multiply by the derivative of this inner function. And the derivative of 4x is just 4. Instead of putting this off to the side, I'm going to put the 4 in the numerator, like this. And now it's clear that these 4's will cancel each other out. So this is going to leave me with y prime equals 1 over x natural log 3. And that's the final answer. Before we do number 12, let me remind you of the relevant rule that we have to memorize. The derivative of arcsine x is 1 over the square root of 1 minus x squared. You just have to memorize that. Also, keep in mind that arcsine is the same thing as inverse sine, in case you ever see it written this way. Anyway, back to the problem. So I will have y prime equals. I see this constant in the front. When you have a constant, you just bring it down and move on. So now I'm going to do the arcsine. So I have 1 over the square root. Instead of putting 1 over, I'm just going to leave that 2 in the numerator. And then I will do my square root of 1 minus. Instead of x squared, because I don't just have a plain x, I have an x minus 1. So I need to do x minus 1 squared. Normally I would say, hey, we don't have a plain x here, so we need to multiply by the derivative of the inner function. But the derivative of x minus 1 is just 1, so that wouldn't do anything. So I think this is a good version for our final answer. I am going to play around with it a little bit and show you a couple other versions. You know that x minus 1 squared just means x minus 1 times x minus 1. So we can very easily expand this. So then we would have this. Then we would distribute the negative sign throughout the trinomial. So you have this. Now you might notice that the positive one and the negative one will cancel each other out. And that would give us this. So here is another good answer for this problem. Before we do number 13, let me remind you about the rule that we need to memorize. The derivative of arctangent is 1 over 1 plus x squared. So as I begin to write g prime, I'm going to apply the rule and do 1 over 1 plus something squared. But instead of putting x, I'm going to put e to the x, since I have this function inside of a function. And that also signals me that I need to do the chain rule and multiply by the derivative of this inner function. but the derivative of e to the x is still e to the x power. I'm going to go ahead and put this up in the numerator though. That's really all there is to it, so this is an acceptable form of the answer. Of course, when you have a power raised to another power, you can multiply those. So here's another form in which you could write the answer. For number 14, we definitely have a function inside of a function, so we will emotionally prepare ourselves to use the chain rule. So starting with the outer function, we have memorized that the derivative of sine is cosine, so I'm going to write down cosine. And then I have the inner function, arccosine x. So the chain rule says I'm not finished until I multiply by the derivative of the inner function. You know how the derivative of arcsine x is 1 over the square root of 1 minus x squared? Well, the derivative of arccosine x is negative 1 over the square root of 1 minus x squared. So we're just going to put that formula right here. Notice that cosine and arccosine are inverse functions, so they essentially cancel each other out. And we're going to end up with just x. And for the final answer, let's put that x up in the numerator, and we get this. So that's it for number 14. Here is the fact that we needed to memorize for problem number 15. The derivative of arcsecant x is 1 over the absolute value of x times the square root of x squared minus 1. I know that's a lot, but we just have to memorize that. To help me remember, I always think to myself, well, first I have to remember that secant is the one that has the absolute value of x in the front. But then I think to myself, these x's like to be together. So they're always next to each other when there's an extra x. Compare that to the derivative of arcsine x. When there's no extra x in the front, the x squared likes to be way over on the right-hand side. But suddenly, when there's an x outside, the x squared rushes over to be close. Anyway, I see the chain rule in our future. Y prime equals. When you have a constant in the front, you just bring down the constant and move on. So here comes this rule. But instead of writing it off to the side like this, I think I will put the 3 right into the numerator. So let me just recopy it real quick like. So that 3 that was sitting there, I'm going to put it in the numerator. And I'm going to have my absolute value and my square root and something is squared minus 1. I'm leaving these empty for a second because we don't have just a plain x. We have x squared. So that's why I'm going to put x squared everywhere there was an x in the rule. So x squared here and x squared right here. So this is going to do a couple of things. First of all, the absolute value. When you square something, it's always positive. So the absolute value becomes redundant. So I'm not going to write the absolute value anymore. It's just x squared. And x squared squared is x to the 4th power. So I will write x to the 4th power minus 1. Almost forgot to do the chain rule. Because we have this function inside of a function, this is not the final answer. We have to go ahead and multiply by the derivative of this inner function. The derivative of x squared is 2x, which I will go ahead and put in the numerator. And then the x in the numerator will cancel out one of these x's in the denominator. And 3 times 2 is 6. So this will be the final answer. Remember how the derivative of arcsecant x looks like this? Well, the derivative of arccosecant looks like this. The only difference is the negative. So let's get started. We will have y prime equals. The derivative of a constant is 0, so I will write nothing there. Bringing down the negative sign, I just have this rule. But you know what? The negative sign is going to turn this positive. So I'm just going to have this rule, but it will be positive absolute value of x, square root x squared minus 1. Remember how the derivative of arctangent x is 1 over 1 plus x squared? Guess what the derivative of arccotangent x is? You guessed it, the same thing but with a negative 1. So let's go ahead and do this chain rule real quick. We will have y prime equals, and here comes the rule. So we have negative 1 over 1 plus something squared. But since it is not just a plain ordinary x, I will put the x over 2 inside of here. And because we have a function inside of a function, I need to now multiply by the derivative of this. When I look at x over 2, I really am thinking 1/2 x, because that would be the same thing. And the derivative of 1/2 x would just be 1/2. Now it does say simplify, so I'm going to play around with this a little bit. Let's start by squaring this fraction. So this will be x squared over 4. Let's go ahead and multiply by this 1/2 now. Obviously 1 times negative 1 will still be negative 1. But in the denominator, this 2 is going to distribute. So I'm going to end up with a 2 right here where the 1 is. And I'm going to have like 2 over 4. So that's going to reduce. So now we have this. It's not considered simplified as long as I have a fraction inside of a fraction. So I always like to add these together and see what happens. I need like denominators though. So I'm going to rewrite 2 as 4 over 2. So this will be 4 plus x squared over 2. When you are dividing by a fraction, you multiply by the reciprocal. Or another way to look at it is, if I have a over b, and I put a 1 over it, this means the reciprocal. So I know it's just going to be b over a. If you have a negative 1 over it, like I have here, I'm still going to do the reciprocal, but it'll just be negative now. So I don't have to think about it very hard. This is going to become the reciprocal. And I will have y prime is equal to negative 2 over 4 plus x squared. And that should be the final answer. It seems weird to end on such a simple problem. But y is equal to a constant, and we know that the derivative of a constant is 0.